The pit organs of snakes. It is thought that the facial pits or pit organs on the head of some snakes are specialized infrared heat receptors. When a rattlesnake strikes, the direction of the strike seems to be guided by the infrared radiation from its prey. A rattlesnake strikes only at warm-blooded prey, and when the prey is dead and at room temperature, the snake will not strike. However, a blindfolded snake strikes correctly at a dead rat that is pulled across the cage, provided the rat is warmer than the surroundings. Blindfolded, the snake cannot be guided by vision, nor is it guided by the sense of smell, for it will strike correctly even at a moving cloth-wrapped electric bulb. The pit organs are evidently involved in sensing the location of warm objects. All snakes that have pit organs feed preferentially on warm-blooded prey, and this further supports the view that these organs are infrared sensors. In the rattlesnake, the pit organs are located, one on each side, between the nostril and the eye. They are connected to many nerves, and this in itself suggests a sensory role for the organ. The sensitivity of the facial pit has been examined by recording the activity in the nerve leading from the organ. A variety of stimuli, such as sound, vibration, or light of moderate intensity, with the infrared part of the spectrum filtered out, has no detectable effect on the activity in the nerve. However, if objects of a temperature different from the surroundings are brought into the receptive field around the head, there is a striking change in nerve activity, regardless of the temperature of the intervening air. How is the infrared radiation sensed? The pit is covered by a thin transparent membrane, and it has been suggested that a rise in temperature in the pit behind the membrane could cause an expansion of the gas with a consequent deformation of the membrane. This, in turn, could be sensed by a suitable receptor. This hypothesis is highly improbable, for a cut in the membrane that opens the pit to the outside air causes no loss in responsiveness, a result that is incompatible with the hypothesis that a pressure change is sensed. We are left with two other possibilities to consider. Either the effect is photochemical, which means that the infrared radiation is absorbed by a specific compound analogous to the light-sensitive pigments in the eye, or the pit organs are sensitive to the slight temperature rise caused when infrared radiation reaches them. The infrared radiation emitted from a mammalian body has low quantum energy, which makes any photochemical effect on a pigment extremely unlikely. Pure infrared radiation can be produced by a laser, and experiments with such radiation of known wavelength provide strong evidence that the mode of reception in the facial pit organ is entirely thermal. Can the pit organs be used for perception of the infrared source in the way our two eyes are used for stereoscopic vision? This seems likely, not only from observations of the precision with which a snake can strike, but also from studies of its brain activity. When infrared radiation falls on the facial pit organ, electric activity can be recorded from the optic tectum, the part of the brain with which the optic nerve is connected. This in itself is suggestive. Although the nerves from the pit organ are completely separate from the optic nerves, the same part of the brain seems to handle visual information, which is known to be stereoscopic, and infrared information. The optic tectum has left and right parts located on either side of the brain. Each part receives input from each eye via the optic chiasma, the point at which the optic nerves from the left and right eye meet. Many of the neurons in the tectum respond to stimulation of the pit organ on the opposite side of the head. This is reminiscent of the way information from the eyes is handled. The crossover of the optic nerve and the optic chiasma is essential for stereoscopic vision and interpretation of distance. Information from the two pit organs is apparently coordinated and interpreted in a similar way, a conclusion in agreement with recorded changes in the neural activity in the tectum when the infrared source is in a position to irradiate both pits at once. It therefore appears that the facial pits indeed provide stereoscopic perception and substantially aid in the precision of estimating the location of prey.